Okay, so if we're gonna make epoxides, the way that we do that, well, we have two ways of doing it. The first way is by taking a double bond and oxidizing it with a peroxy acid. Okay, so there's two peroxy acids that we use, MCPBA and peroxyacetic acid. Can you see why that would be called peroxyacetic acid? Right, that looks like acetic acid, right? And this looks like benzoic acid in a way, metachloro benzoic acid, but it's peroxy benzoic acid. Okay, so there's our peroxy right there. So the two agents we use, MCPBA and peroxyacetic acid. A lot of times you'll see MCPBA, you'll see this acronym with a lowercase m. It doesn't matter. I don't think it matters at all. See, it's uppercase here. So either way, MCPBA, that's what the structure is. Peroxyacetic acid is the other one. So if we take either of these peroxy acids to a double bond, that's what we get. Okay. Now, the process is stereospecific, of course, I guess. We're going to take then oxygen and add it to one side of that double bond. Do you see that? So the oxygen's going to go maybe here, right? Or here. Can you see that? Okay, if we do it like this. All right. Now, epoxides can also be formed from halohydrins. So in chapter 9, I think it's section 9.5, we found that we can make a halohydrin by taking, I don't even remember if this is on the next slide or not, so please forgive me, okay? We can take a halohydrin and do Br2 and water, all right? And we learned the mechanism for that before too, all right? And so this is going to give us a trans halohydrin. Do you see that? Halohydrin, okay? Now, if we have a trans halohydrin, then we can treat it with hydroxide and get an epoxide. There's our epoxide. All right, so let's look at the mechanism for that. So the mechanism is we take the hydroxyl and we deprotonate it. Proton transfer. I'm just circling stuff, aren't I? I'm in a circling mood, I guess. So proton transfer, hydroxide, boom, deprotonate that. And now we have, look at this, a nucleophile. Okay, you see that? And the nucleophile does a backside attack at this carbon where the halogen is. Now, it's important, I think it's easier if you can see it from the side. So remember now, if you've got a cyclohexane, your backside attack, these guys, if this guy is in the axial position, this one's also going to be in the axial position if they're trans, right? 1,2 trans is both an axial. And so can you see how that's actually not as far reaching as it looks. This looks clumsy. This makes it look easier to see if we do it like that, if you can look at it from that angle, okay? And that being the case, this expels the bromide off the back. All right, so the epoxide, or rather the alkoxide ion, functions as a nucleophile, which we said over here. There's a nucleophile. The alkoxide ion functions as a nucleophile in an intramolecular SN2 reaction, eliminating the halide as a leaving group. All right. So you've got two ways to make epoxides. Look at the overall stereochemistry that occurs through the halohydrin intermediate. All right, in both cases, they turn out to be cis, right? Okay, now pause the video and practice with Skill Builder 14.3.